What's up, y'all? I'm Tom, and this is Like a Math Class. In this video, we're looking at a couple examples of multiplying and dividing scientific notation numbers, or really big numbers and really small numbers, written in exponential form. Let's get to it. This example says, without a calculator, write 4 times 10 to the 5th power times 2.5 times 10 to the negative 3rd power in the form a times 10 to the k, which is what we say is scientific notation, where a has to be bigger than or equal to 1 and a has to be less than 10, and k is an element of the integer set, which means a positive or a negative number. So let's start by just writing this out. 4 times 10 to the 5th, and then I'm going to do times 2.5 times 10 to the negative 3. Now, anytime we're multiplying, right, this is multiply 4 times this times this times this. So we've got 4 things that are all being multiplied together. There's no reason that we can't regroup these. So let's do that. So let's do 4 times 2.5 times 10 to the 5th times 10 to the negative 3rd. So 4 times 2.5, that's going to be 10. So now we've got a value of 10 right there. That's going to be times. Now if we've got the same base, different exponents, what we saw in our rules of exponents video is that we're going to add those two exponents. If we have a to the m times a to the n, this is the rule that we used, then we have a to the m plus n. So here, this means we've got the same bases, different exponents, add those two things together. Same bases, different exponents, let's add those two things together. So we're going to have 10 to the 5th plus a negative 3. So 10 to the 5th plus a negative 3 is simply 10 squared. But notice this thing is equal to 10 in our standards, or in our scientific. Notice this thing is equal to 10 and our scientific notation says that this has to be greater than or equal to 1 and less than 10. So we have to actually change this as well. We have to put this into scientific notation as well. So we're going to move the decimal point 1 unit over. So now we're going to have 1 times 10 to the 1st power times 10 squared. So now once again, we have the same bases, different exponents. So we're going to add those two things together. So we're going to have 1 times 10 cubed. And there is our solution to these two things being multiplied together and putting it into the scientific notation form. Let's look at one more example. If x is equal to 3 million and y is equal to what is that? That's 10, 100,000, 10,000, 100,000, million. So 15 millionths. 15 millionths. You have to put that THS on the end for the decimals. So y is equal to 15 millionths. Show that the quotient of these two things, when you divide these two things together, that you're going to get 2 times 10 to the 11th power. Okay, so first off, show that means show all the logical steps that will lead you to this solution. So it's almost like you need to show your work for all of this to happen. So the first thing I'm going to do is I'm going to change 3 million into scientific notation. So I'm going to let x equal 3 times 10, and let's see, we need to move this over 1, 2, 3, 4, 5, 6 places, so 10 to the 6th power. And then y equals, let's see, now I've got to move this over to the right, so I'm going to go over 1, 2, 3, 4, 5 places, so that's going to be 1.5 times 10 to the negative 5th power. So again, a really small decimal, we have a negative exponent. A really big number, we've got a positive exponent. So now show that x over y is equal to this. So let's just do that. 3 times 10 to the 6th power over 1.5 times 10 to the negative 5th power. So we know that if we are, we've got multiplication and we've got some like terms, and with our fractions, we could separate these into 2 separate parts, or 2 separate fractions. So we could have 3 over 1.5, and we can make that times 10 to the 6th over 10 to the negative fifth. So 3 over 1.5, that's going to equal 2. And then we've got 10 to the sixth over 10 to the negative fifth. So remember, this is going to be times 10 to the sixth minus a negative 5, because if we are same base, if we're dividing same bases with different exponents, then we subtract those two things. So ultimately, we're going to be left with 2 times 10 to the 11th power. And that is our solution there. So that's how we can use scientific notation with multiplication and division. I hope that was helpful. If it was, give me a thumbs up, and I'll see you in the next video.